This video is about using logarithmic rule for integration to integrate a rational function and integrate trigonometric functions. Logarithmic rules for integration. The integral of 1 over x dx is natural log of absolute value of x plus some constant c. Integral 1 over u du is natural log of u absolute value plus c. Integral 1 over ax plus b is 1 over a times natural log of ax plus b absolute value plus c. Example 1. Find the definite integral of integral 9 over 4 minus x. So let u is equal to 4 minus 5x. Find d over dx. D over dx is derivative of 4 is 0. Derivative of 5x is negative 5. Multiply each side by dx. So we get dx is d over dx minus 5 times dx. So we get du equals to minus 5 dx. Or solve for dx. So dx equal to minus 1/5 du. Now we substitute for minus 5x is equal to u, and dx is minus 5 over du. So we replace the dx by this. So we can move the 9 out and minus 5 also. So it becomes 9 over 5 integral 1 over u du. Now by the log rule, this is natural log of u. Absolute value, now we replace the u is equal to 4 minus 5x and add c. So the answer is negative 5 over 5 natural log of 4 minus 5x absolute value plus c. Example 2. Find the indefinite integral of x squared over 5 minus x cubed minus times dx. Let u is equal to 5 minus x cubed. Differentiate with respect to x. d over dx is 5, derivative of 5 is 0. Derivative of x cubed is negative 3x squared. Now multiply each side by dx. So it becomes dx equal to d over dx equal to minus 3 times 3x squared dx. Dx cancel, we got du is equal to minus 3x squared dx. So we solve for dx, divide both sides by minus 3x squared, so you get dx equal to minus 1 over 3x squared du. Now we substitute, replace 5 minus x squared equal to u, and dx we replace with negative minus 1 over 3x squared du. So we can simplify x squared cancel with x squared and move the negative 1, 3 outside. So we have a negative 1/3 in natural log of 1 over du, and the derivative of 1 over u is, antiderivative of 1 over u is natural log of u, absolute value. So you have a negative 1/3 natural log of u. Now replace the u by 5 minus x cubed. So we have a negative 1/3 natural log of absolute value of 5 minus x cubed, and you add c plus c. Example 3. Find the indefinite integral of x squared plus 4x over x cubed plus 6x squared plus 5. So let u is equal to x cubed plus 6x squared plus 5. Differentiate with respect to x. So we can d over dx is equal to derivative of x cubed is 3x squared. The derivative of x 6x squared is 12x, and derivative of 5 is 0 because it is constant. Now we multiply each side by dx. So we have a dx times d over dx equal to 3x squared plus 12x times dx. Dx cancel over dx, you get du. So you have a 3x squared plus 12x equals to dx. Now divide by 3x squared plus 12x. So you get 1 over 3x squared plus 12x du is equal to dx. So now we replace the dx 1 over 3, it looks like we can factor out 3. So you get 1 over 3 times x square plus 4x du. So now we're going to replace dx with this one, du over 1 over 3 times the x square plus 4x du, and x cubed plus 6x square plus 5 with the u. So we substitute x cubed plus 6x squared plus 5 equals to u, and dx equals to 1 over 3 times the x squared plus 4x du. So we have this one. Square root integral of x squared plus 4x over u times 1 over 3 times x squared plus 4x du. Now notice these two cancel out, and you have 1/3 we can take out. So become 1/3 integral 1 over u du. And the antiderivative of 1 over u is natural log absolute value of u. So then we have 1/3 natural log of u. Now we substitute u is equal to x cubed plus 6x squared plus 5 and add c. And that's the answer, 1/3 natural log absolute value x cubed plus 6x squared plus 5 plus c. Example 4. Find the antiderivative of natural log of x squared over x. So let u is equal to natural log of x. So differentiate with respect to x. So it will be d over dx 1 over x. Multiply each side by dx. So this becomes dx and d over dx equal to 1 over x times dx. Now we dx cancel out. You get du is equal to 1 over x dx. Now we isolate dx, multiply both sides by x. So it becomes x times du, x times 1 over x dx. Cancel out x and become dx. So when you solve, you get dx equal to x times du. So now we're going to substitute natural log of x equals to u and dx equal to x times du. So now we have integral u square over x times du. X cancel with x. So you have integral of u squared du. Now this is exponential. We can apply the power rule, which say un plus 1 over n plus 1. So this becomes u to the 2 plus 1, 3 over 3. Now we substitute u is equal to natural log of x. So they become natural log of x to the power 3 over 3 plus some constant c. Example 5. We're going to find the antiderivative of or indefinite integral of cube root of x over cube root of x plus 2. So it looks like in this case, this is more complicated. We're going to choose let u equals to cube root of x plus 2. So let's rewrite cube root of x in rational exponential form, so which is x to the 1/3 plus 2. So now we can move the 2 to the left. So we can u minus 2 equal to x to the 1 cube. Now we cube each side, and you got u minus 2 to the 3, or x to the 1/3 to the power 3. So you got u minus 2 to the power 3 is equal to x. Now we differentiate with respect to x. So this becomes 3 times u minus 2 squared du over dx equals to 1. Multiply each side by dx. So if dx is going to cancel with dx, we get 3 times u minus 2 squared du is equal to dx. So now we're going to substitute cube root of x plus 2 equals to u, and dx equal to 3 times u minus 2 squared du. And cube root of x is equal to u minus 2. So now we multiply with u minus 2, we can factor out to 3. Multiply u minus 2 times u minus 2 square, which is u minus 2 times u square minus 4u plus 4. So we replace you multiply further u minus 2 times u square minus 4u plus 4, which can become u cube minus 6u square plus 12u minus 8. So this becomes 3 times integral u cube minus 6u square plus 12u minus 8 over u. Now we divide individually. So this will be 3 times integral u cube over u minus 6u square over u plus 12u over u and minus 8 over u. So we simplify, we get 3 times integral u square minus 6u plus 12, and this will be 8 over u. Okay, so we have a 3 integral of u square minus 6u plus 12 minus 8 over u. Now the integral of u square is in power rule u cube over 3. Here also is power rule u square over 2 times 6. The integral of 12 is just 12u. Now this is the integral of a times natural log of absolute value u, and add the constant c. Now we distribute 3 and simplify. So 3 times 3 is u cube. 3 times 6, 18 divided by 2 is 9u square. 3 times 12, 36. 3 times 8, 24. Natural log of u. Now we replace u's by a cube root of x plus 2. So you have a u become cube root of x plus 2 to the power 3 minus 9 times cube root of x plus 2 to the power 2 plus 36, and u become cube root of plus 2 minus 24 natural log of absolute value of cube root of x plus 2, and add the constant c. We can expand, and then we can simplify. It gives you negative 24 natural log of cube root of absolute value cube root of x plus 2 minus 12 times x to the power 2/3 plus 12 times x to the 1/3 plus x plus 44 plus c. So we have an integral of theta times cotangent theta 2 theta squared. We can rewrite cotangent 2 theta square using this formula. Cotangent u is equal to cosine u over sine. So this becomes cosine 2 theta square over sine 2 theta square. So now we have integral of theta times cosine 2 theta square over sine 2 theta square. So we can let u is equal to sine 2 theta square, and we differentiate with respect to theta. So we become du over d theta cosine sine 2 theta square become cosine 2 theta square times the derivative of 2 theta square with respect to theta, like a chain rule. So now we can write cosine 2 theta square, and the derivative of this would be 2 times theta square become 2 theta, so 2 times 2 theta would be 4 theta. So now we can factor 4 theta outside, and we have a 4 theta and cosine 2 theta squared. So now we have a du over d theta is 4 theta times cosine 2 theta squared. So we're going to isolate d theta. So we must multiply both sides d theta. So we become d theta times du over d theta equal to 4 theta and cosine 2 theta squared d theta. D theta cancel with d theta, we left with du is equal to 4 theta cosine 2 theta squared times d theta. Now divide by 4 theta cosine 2 theta squared. So we can 1 over cos 4 theta cosine 2 theta squared du, and also so this cancel out with just d theta. So now we substitute in the original integral sine 2 theta square equal to u. So that's become u here. And just keep d theta replaced with 1 over 4 theta cosine 2 theta square du. And just copy theta and cosine 2 theta square. And now cosine 2 theta square cancel with cosine 2 theta square. And theta cancel with theta, and we have 1 over 4 integral 1 over u du. And 1 over u, the integral is very simple, natural log of absolute value of u plus constant c. Now we replace the u is equal to sine 2 theta square. So this becomes 1 over 4 natural log of absolute value of sine 2 theta square, absolute value plus sub plus constant c. Example 7. We're going to find the indefinite integral of cosecant theta cotangent theta over cosecant theta minus 1. So we're going to take the let u is equal to cosecant theta minus 1. We differentiate. We can d over d theta. Cosecant theta becomes minus cosecant theta cotangent theta. And we solve for d theta, mean multiply each side by d theta. So you multiply d theta, become d theta and d over d theta. Multiply d theta here, so becomes minus cosecant theta cotangent theta d theta. D theta cancel out, easy to u. So we have d equal to minus cosecant theta cotangent theta d theta. And now we divide both sides by this one. So we have 1 over negative cosecant theta cotangent theta d equal to d theta. And now we're going to substitute. So we're going to substitute cosecant theta minus 1 is u. And d theta equal to 1 over minus cosecant theta cotangent theta du. So cosecant theta minus 1 is u. Cosecant theta cotangent theta d theta is 1 over negative cosecant theta cotangent theta du. Now these two cancel, gives a negative 1 over integral 1 over u, and which is minus natural log of u. Now we replace u or substitute u is equal to cosecant theta minus 1. So the answer is negative natural log of cosec, absolute value of cosecant theta minus 1 plus constant c. Okay, next is second fundamental theorem of calculus. If a function f is continuous on an interval containing a, then for every x in the interval, the derivative of integral from a to u f of t dt is equal to f of ux times d of dx of this ux. So all I have to do is you just replace the t with the upper limit and then differentiate with the upper limit with respect to x. So here's an example 7. Find f prime x. F of x is 0 to x cube in 2 over t plus 3 dt. So f of x is integral from 0 to x cube, 2 over t plus 3 dt. So we're going to differentiate. So f becomes f prime x, and this we write d over dx of 0 to x cube, 2 over t plus 3. All I have to do is by the second fundamental theorem calculus, replace the t by x cube upper limit. So you're going to have do over t plus 3, just indicating we're going to replace t is equal to x cube and then multiply by the derivative of the upper limit x cube. So this becomes 2 over x cube plus 3 times the derivative of x cube is 3x squared. Now we simplify 2 times 3x squared becomes 6x squared over x cube plus 3. So here example 8, we're going to find the area of the region bounded by the graphs of the equation. So this is the bounded by this graph of y equal to x cube plus 4x over x squared, and line x equal to 1, line x equal to 6, and y equal to 0. So the area formula is integral from a to b f of x dx. So now we replace that's the formula for the area. A is the lower limit 1 and the b is upper limit 6, and the f of x is this one. So the area becomes integral from 1 to 6 x cubed plus 4x over x squared dx. Now it's straightforward. You can see that we can easily divide the numerator by the denominator. So that's what we're going to do. So we divide x cubed over x squared gives you x. Divide 4x over x squared gives you 4 over x cubed x. Now we can break it down into two integrals. Integral from 1 to 6 x dx plus 4 integral from 1 to 6 1 over x dx. Now here we apply the power rule. So it becomes x squared over 2, and we substitute 1 to 6 plus 4, and that's the integral of 1 over x is natural log of absolute value of x. And we substitute limits from 1 to 6. So we're going to substitute 6 top limits. So this becomes 6 squared over 2, and then subtract, and we substitute low limit 1 in x squared 1 squared over 2. Same thing, plus we're going to do the same thing. First substitute the upper limit, so this becomes 4 times natural log of 6, and then minus, and substitute the low limit, natural log of 1. Now we're going to simplify. Well, 6 squared is 36, divided by 2 is 18. And that's 1 squared with 1, so it'll be negative 1/2. And then 4 times natural log of 6, and natural log of 1 is 0, so we have just, and we put in the calculator, and then we give you 24.667, and that's rounded to 3 decimal places. Okay, example 9, finding the average value of the function. So to find the average value of the function over the given interval, and this is the function f of x equals 6 times x plus 4 over x squared. The interval is 1 to 4. Now the formula for the average value is 1 over b minus a, integral from a to b f of x dx. So now we can replace f of x is equal to 6 times x plus 4 over x squared. So a is 1 and b is what? 4. So we have 1 over 4 minus 1, integral from 1 to 4, 6 times x plus 4 over x squared dx. Now again, it's a simple, we can divide individually, so we can factor 6. 4 minus 1 is 3, so it becomes 6 over 3, integral from 1 to 4, x over x squared plus 4 over x squared. Simplify, 6 over 3 is 2, integral from 1 to 4, x over x squared becomes 1 over x. And we can move the x squared to the top, make it 4 times x3 minus 2. Now we can separate the integrals. We have a integral 1 to 4 1 over x dx plus 1 to 4 4 x3 minus 2 dx. Now we're going to find the antiderivatives. So the antiderivative of 1 over x is natural log of x, and we substitute the limits 1 to 4, and then the integral of x3 minus 2 is minus 2 plus 1 or minus 2 plus 1, and then we're going to substitute limits 1 to 4. Okay, so first simplify or substitute. Let's see, bring down 2. First put the upper limit, because natural log of 4, and then minus natural log of 1. And then here minus 4 over x, we simplify. X to the minus 2 plus 1 is x to the minus 1. So that we can bring it down to as x, and minus 2 plus 1 is minus 1, so we have negative 4 over x, low limit limit from 1 to 4. So let's simplify this one. It will be natural log of 4, this becomes 0, put the upper limit, become 4 over 4 minus, put the low limit 1, so it will be 4 over 1. Okay, so we simplify further, so we have it 2 and natural log of 4, and minus 4 over 4 is 1, negative 4 over 1, and this minus makes it positive 4. So and then further simplify, we have 2 times natural log of 4 minus 4, 1 plus 4 is plus 3. Put on the calculator, you try to get 8.773. And that's the average value of the function.